In this video, we are going to learn about parabolas. Basically, it's the second part of the lesson that we have on polynomial functions and parabolas. So really quickly, one of the applications that you can have for a parabola is basically what you're looking at here. It's a very interesting application. Basically, if you have a parabola and there are rays of light that come in and they bounce off of the internal part of the parabola. Maybe you've ever seen these at satellite dishes and stuff on top of houses and stuff, but basically it can take all of the energy and it can focus it onto one point. And so what it's basically trying to show to you is you can literally cook something like a steak using just a parabola. So it's a very interesting application that I wanted to show to you. And basically, this point right over here is called the focus. Okay, so all of those rays of light, no matter how they bounce off, they always are going to bounce off and head towards the focus. So anyways, let's go ahead and establish some formulas for parabolas and actually study them. Now, one thing that I will mention to you before we begin with this is you already know one of the equations of a parabola, and the equation looks like y is equal to x squared. If you recall, that's something that you already know, okay? And if you recall, it's basically a parabola that opens upwards, right? And so you've learned to transform that parabola in different kinds of ways. In this chapter, in this lesson, sorry, what you'll notice is this same parabola, it can open upwards, it can open downwards, right? So it can open upwards, downwards, it can open right, and it can open left. So you want to pay special attention to the types of things that make the parabola behave and work in a certain kind of way, right? So first things first, in a parabola, one of the things that you need to know is that it has a vertex, and the vertex is at point h comma k. So you'll notice in every single one of these equations, each one of them has an h and a k. And you'll also notice that the h is always written along with the x's, and the k is always written along with the y's, right? So take a moment, look at all of the formulas, and notice that the ones that open upwards always have x minus h and y minus k. The ones that open right or left have x minus h and y minus k. So what I mean to say is x minus h and y minus k are always going to be together. So you might be looking at these going like, well, what's the difference between them in the first place, right? So if you look at the ones that are for upward and downward, you'll notice that the one for upward and downward, they both have the x minus h term is squared, right? So the x minus h term, you'll notice, has a square on it. So for both of them. So then the question is, what's so different about the one that opens up versus the one that opens down? It all really comes down to that negative symbol right there. Notice that as soon as that negative symbol exists, this parabola will open downwards. But if that negative symbol does not exist, then it's going to open upward. Now, if you want to have an idea of what it means to open upward, well, basically an upward parabola looks like this, whereas a downward parabola looks like this, okay? And basically, if you continue to draw in this same exact manner, then when it comes to opening a right parabola, it faces right like this, and one that faces left is like this. Now, notice how in opening upward and opening downward, both of these had a x minus h term that was squared, and then they had a y minus k term that was not squared. Whereas in a parabola that opens right, you'll notice that the y minus k term is actually the one that's squared. All right, so notice how y minus k shows up right over here, and that's squared. And the same thing goes for opening left. Y minus k is squared. However, x minus h is not squared. Okay, so that's one of the ways to tell which one are you looking at. You'll notice that in the one that opens right, the y minus k is squared, and the one that opens left, y minus k is squared. So basically anything opening sideways, the y minus k is squared, whereas anything opening upwards or downwards, the x minus h is squared. So I hope that makes sense to you. Then notice how opening left, so I keep going back and forth to help you understand what are the differences between the formulas. When opening left, notice how there's a negative sign in front, right? So the same thing applies for the other one where if it was opening downwards, there was the negative sign. Okay, now you're probably looking at a certain component going like, yeah, but what does this mean, right? So notice how there's an A term in all of the four formulas, whether you're opening upward or downward or opening right or opening left. You're probably wondering, where did that A come from? What does that A actually stand for? So that is a discussion that we want to have, right? So basically what we're going to do is we're going to create a little diagram that will help you understand a few things, all right? Now as we go through it, there's important terminologies that you need to know. One of them that you need to know is vertex. Another one that you need to know is focus. And another one you need to know is directrix. Okay, so distance from vertex to focus or from vertex to directrix is A, right? That's not sufficient to just understand what A is. So I want to show you a handful of pictures to help you understand, all right? So let's take a look at the first one. Now, actually, when I say first one, let's go to the easiest one first, and let's go to the one that opens upward, okay? So here is a parabola that opens upward, and we're looking at diagram C specifically, all right? So let me label it first. Opens, opens upward. This parabola over here. Now, in this parabola, there's several important key components. Notice that first off, it's got a vertex at h comma k, and of course it's facing up. Now in front of this vertex is a focus. So that point right there is called a focus. All right. And then behind that graph, behind the parabola is a line that looks like this over here. And that line is called the directrix. All right, that line is called the directrix. Now, I know that those are two very new looking things to you, but when I began this lesson, I talked about how if there was rays of light coming from the sun, they would all bounce off and go to the focus of the parabola. So that's an important part of your understanding of parabolas. Now, the axis of symmetry is not that important right now, so let's not focus on the axis of symmetry. But basically, you're looking at a parabola, you're looking at a focus, and you're looking at a directrix. Now, you'll notice that there is a vertex at h comma k, but that's something I told you from the beginning. Just for sake of completeness, however, what I'm going to do is I'm going to write there that this is the vertex, like that. Okay, now what's the deal with A? Because we understand where the H comes from, we understand where the K comes from. Those are basically values from the vertex, the X and the Y values, right? But what exactly is the deal with A? So if you were to start from the focus and go to the vertex, or if you were to go from the directrix, there's the directrix, all the way to the vertex. all right? That distance is called A. That distance is called A. It's always going to be a positive value, and it's always going to be, of course, the same value, right? So sometimes you'll notice in the questions that they give you the distance between the vertex and the directrix, and sometimes they give you the distance from the vertex to the focus. And other times they'll even give you the distance from the directrix to the focus, and you'll be like, well, that's basically twice A, so I'm going to divide it by 2. All right? So altogether, that is how we figure out what A is. All right, and eventually when we try the problems, you'll understand a little bit better, and you'll notice in diagram C, I've once again got the formula written right below. Okay, now let's go ahead and take a look at diagram D. And in diagram D, basically what you have here is a parabola that opens downward. Now in a parabola that opens downward, it's essentially all the same as one that opens upward. Notice that it still has a vertex, okay? It still has a directrix. It still has a focus. But one thing that I want to remind you of, though, is notice how the focus is always in front of the parabola, all right? And when we mean by in front is the parabola opens up into the focus, all right? So you want to remember that is the focus is always in front and the directrix is always behind, all right? So notice how the directrix is behind the parabola, right? No matter which one of these four you're going to be looking at, the directrix always runs behind the parabola, the focus is always in front of the parabola. And specific to the parabola, we're talking about that vertex, all right, relative to the vertex. Excuse me. Now, only thing to remember is there's a negative sign in front of this formula. And if it helps for you to make that connection, then please do so. Recall when we learned parabolas, this was the equation of such a parabola. But if you were to take the parabola and reflect it over the x-axis, recall that this is a transformation where you're basically flipping over the x-axis. So you change the sign on the y. And that's where we got the negative sign from, by the way. Okay? All right, now, what we're going to do is we're going to look at two parabolas that you're not familiar with as much, okay? And that's the one that faces right and the one that faces left. Now, the one that faces right, first off, you want to get used to the focus and the directrix. Notice how the focus is right here and the directrix is behind. So all that is still taken care of. It's the same exact pattern as before. And the logic still applies that you look at where the vertex is, and if you count the number of units, that's A units, behind the vertex is the directrix, and A units in front of the vertex is still the focus. All right, so if the parabola opens towards the right, the focus is going to be in front of that parabola, like that, right? Whether it opens left or right, it's always going to be in front. So you want to kind of keep track of that as well. Okay, so I remind you again that when it comes to opening right and opening left, you'll notice that the y minus k term is what's squared, and the x minus h term is the one that's not squared. And it applies the same way for a left-facing parabola. The y minus k term is squared, and the x minus h term is not squared. That is unlike the other two where it kind of swaps around. Now, just one last little note to make is notice how once again, a left-facing parabola, you've got the negative sign in front of the 4a. Okay, so now that we've gotten used to the parabolas and like their formulas and stuff like that, I know that's a bit dry, but we kind of had to go through that before we can continue with understanding the formulas and applying them. So here is the first type of problem that we're going to try. All right, it says find an equation of the parabola with the vertex at 0, 0 and a focus at 3, 0. And then it says graph the equation. So what we're going to do is we're going to be a little bit more intelligent about this, and we're going to first begin by making a graph. All right, my advice always to students is to first try making a graph whenever you're hit with a question like this. Okay, so I'm going to go to a vertex of 0, 0, which is right over here. All right, I will label it 0, 0, and I know that that is my vertex. Okay, then you're going to go to 3, 0, and you're going to make a focus there. Now, how do I know, right? How do I know that this parabola is going to be opening upwards? What did I say earlier that talked about this? So let me just kind of change one thing. I accidentally made a dot at the wrong spot. So how do I know that this parabola is going to open sideways towards the right? And the answer is because of the fact that the focus is always in front of the vertex. You know for a fact that this parabola is going to be looking like this over here. All right, so that is my parabola because the focus is always in front of the vertex. Now, one thing I will recommend is you take a moment, because these equations are relatively new, and you go to the equations and you make sure that you write it down correctly. So you go to the equation for something that's facing towards the right, and the equation in diagram A says y minus k whole squared. So y minus k whole squared is equal to positive 4a multiplied by x minus h. All right, that is the equation of such a parabola. Now, we understand what h and k are, right? We know that h and k is basically the coordinates of the vertex, so that would be 0, 0. But after you have taken care of that, as a common question students ask is, what should I do with x and y? Just like in the equation of a line, you don't mess with the x and the y. So we're going to leave the x and the y alone, right? And the h and the k are 0, 0. But really what it comes down to, and what's new in this lesson, is what's the value of a, right? What does a stand for? And so let's go ahead and repeat what we said earlier. A is the distance that happens between the point 0, 0 and 3, 0. So how many units is that? That's 3 units. Remember, it's always a positive value. So A is equal to 3 units. And because A is equal to 3 units, you're going to go ahead and update that in the formula, right? So the formula will look like the following. Y minus 0 squared is equal to 4 times 3 times x minus 0. And then notice how y minus 0 is simply y, so you end up with y squared. And 4 times 3 is 12, so you end up with 12 there, 12x. And that is as far as you need to go with that problem, and you can stop right over there. All right, the question then says to graph the equation. Well, guess what? We already graphed the equation, right? That is the graph of the equation. I usually find that working backwards with these helps a lot compared to the way that the book tries to explain it to us. Okay, the next one says, can you analyze the equation? Now, when you're analyzing them, basically you're telling a handful of things. All right, so let's go through this. You're going to tell whether this is opening, which way it opens. All right, so let's just write down opens. All right. Another thing that you're going to analyze when it comes to a parabola is you need to figure out what the vertex is. You need to figure out what the focus is. You need to figure out what the directrix is at. Okay, so those are types of things that we analyze. And then of course, you know, and you don't have to number them the same way. In analyzing, we need that graph. Okay, so let's go ahead and start. You want to consult your equations from previous. right? And see which one of the equations does this one resemble. And notice that the y term is squared, right? Here's how I tell. Notice how the y term is squared and the x term is not. Okay, so what we can tell is that this is certainly going to be a parabola that opens sideways, right? Because the y term is squared, but the x term is not. But then the question is, which way does it open, even if we're talking about sideways? Does it open right or does it open left? And for that, you'll notice that there's a positive 8 right over here. Because there's a positive 8, what that means is it opens towards the right. So in our analysis, the first thing that we'll write down is this parabola opens right. Okay, or it's facing towards the right. Okay, step number 2. It says, what's the vertex? Well, let's think of it this way. When it comes to a parabola that opens right, we just dealt with it. We know that the equation is y minus k squared is equal to 4 multiplied by a multiplied by x minus h, right? And having said that, you know that the vertex always shows up at h comma k. So if you guys take a look at the form, you'll notice that the form and the equation have a slight, what looks like a mismatch, right? But really it's not. What's essentially happening is in our equation is actually supposed to mean y minus 0 squared is equal to 4 times 2 and then x minus 0. You see that? So if you're wondering why did you pick the number 4, it's because remember in the formula it's 4 times a, right? 4 times a. So that 8 really stands for 4 times 2, like this, right? So having said that, you can actually tell that the vertex in our equation is going to be at 0, comma 0, right? Remember it's x comma y, so you have to keep track of that. So you can go back and you can go ahead and make a note that you have a vertex now, and the vertex is at 0, comma 0, like this. Okay, now let's continue to the next thing. You want to go ahead and tell where the focus is going to be, right? And at that point, I would recommend, if it's not making too much sense to you, then go ahead and try to graph it, okay? Meaning skip ahead to step number 5, which is to make a little graph, all right? It really helps. So if you guys notice in this graph, all right, let me just take a moment. All right, so you know that you have a vertex at 0, comma 0, all right? And then what we know is that the value of a is equal to 2. So you're going to go 2 units in front of the parabola. Remember, it's facing right. You're going to go 2 units in front of the parabola and 2 units behind the parabola, and you're going to make a focus and then a directrix respectively. Okay, so 2 units in front of 0, comma 0. So the coordinates of the vertex are 0, comma 0. So 2 units in front of it would be what? 2, comma 0. And 2 units behind it would be the directrix. And so I'm going to make a line through here. All right. One more time. This is 2 units behind. And so that line is, remember, the directrix is a line. So it's, you tell an equation for it. That would be at x is equal to negative 2. All right. And just to kind of drive the point home, like we said, this is a parabola that's opening towards the right, like this over here, similar to our last example, right? And notice that there's 2 units in front of the parabola, and there's 2 units behind the parabola. And where did we get that 2 from? We got it from right over here. And how did we figure that that number was 2? We looked at the 8, and we asked ourselves, 4 times something gives me 8, and therefore that something must equal 2. So that's how we ended up with the 2 that we have right there. So in our analysis, we kind of have already done the graph, but what we can tell more than that now is that the focus is going to be at 2, 0, and we know that the directrix is going to be at x is equal to -2, like that. So to summarize, when we talk about analyzing the equation of a parabola, we're basically talking about which way it opens, what the vertex is, the focus and the directrix, and the graph. But as I told you, at some point, usually the graph and making it is a lot quicker, and it makes it easier to make sure that you've got everything else correct, right? And I guess the one thing that is like your foot in through the door is to be able to make sure that you've made the connection that the number 8 is really represents 4a from that equation right there. Okay, now let's go ahead and analyze yet another one, okay? So if you want to pause the video and you want to try this one by yourself, by all means, you are welcome to do so. So the first thing that we're going to do is figure out which way does this open. Now I can tell that this parabola is of the format x minus k squared is equal to negative 4a y minus h. Or is it the other way around? I think we just have to change those a little bit, right? So it's supposed to be x minus h and y minus k, right? So I know that this is the format of the equation that I have. And if you're wondering how did you tell that, it's because notice that the x is squared and the y is not. So I'm going to use this particular formula. It's the only one where the x is squared and the y is not. Now if you're wondering why do you have a negative 4a, is because the question has a negative 12 there. And a can't possibly be negative. A is always a positive number, right? So let's tell a few things, and you'll notice that it's so easy to analyze this parabola. One of the things, and a lot quicker now, we can say is, well, basically this equation right here is essentially x minus 0 squared is equal to negative 4 multiplied by what gives you 12? That would be 3, right? So negative 4 times 3 multiplied by y minus 0. So using that logic, we can tell where the vertex is at. Once again, the vertex is going to be at 0, 0, right? So, and not just that, notice that we can also tell what the value of a is. The value of a, right, the value of a is 3. And finally, the last comment to make is we can also tell that this parabola is going to open towards the, right, so opens downward. Again, you are welcome to take a look at the equations that we have, but we learned that when the x terms are squared and the y term is not, it opens vertically, upward or downwards. And when you have a negative sign, you know that it opens downward. So really quickly to summarize this and then make a graph, we know that this parabola opens downwards, okay? Next thing, we know that the vertex, right, the vertex is at 0, 0. We know that the focus is going to be 3 units, right, below the vertex. We know that the directrix is going to be 3 units above the vertex. And finally, what we're going to do, notice how I didn't fill in the focus on the directrix, and I do that on purpose, by the way, just so that you're convinced of it. I quickly make the step number 5 thing first, and the quicker you can kind of make this connection, the quicker you can analyze this. But what I'm saying is, for visual learners, it usually helps to analyze the graph and then tell the focus and the directrix. So again, vertex is at 0, 0. And you know that 3 units in front of the vertex, remember it opens downward, right? So if it helps, you can make a parabola that opens downward before you do anything else, all right? Now go 3 units in front, right? And that's actually 0, comma, -3. And you know that that is the coordinates of the focus. So I'm going to go here, I'm going to write down 0, comma, -3 are the is where the focus is at. And then 3 units behind, right? 3 units behind that vertex. So let's just go about equal amount of distance. All right, 3 units behind, 3 units, all right? That right there is the line y is equal to -3, right? So we can go ahead and write down that the directrix is at y equals -3. And once again, we have analyzed the equation. Okay, now the question says find the equation of the parabola. So this time we're going to find the equation. We're not analyzing an equation. We're finding an equation, and they're giving us a few hints. It says that first of all, it's got a focus at 0, 4, and the directrix is the line y equals -4. So you might be looking at this going like, where's the vertex at, right? And so that's the type of things that we're going to tell. But I'm going to stick to my advice to you is I would highly recommend whenever and at any point that you can go ahead and graph the parabola, try to do this first, okay? It makes things a lot easier. Try to complete this first. You'll find that all of a sudden the problem is a whole lot easier. So let's go ahead, take a moment, and graph this. All right, so here's what we have. You're going to go to 0, 4, all right? 0, 4, right about here. You're going to label this as the focus. So the focus is at 0, 4. Then you're going to go to the horizontal line y equals -4. All right, so that would be back over here, and that's y is equal to -4. Remember, this is the directrix. The directrix is always behind the parabola. The focus is always in front of the parabola. Now, time to put things together. Notice that you don't know where the vertex is, right? You don't know where it is, but you know that the distance between the focus to the directrix is basically twice the distance between the focus and the vertex, or the vertex and the directrix, right? If you want something a little bit more mathematical, you know that from the focus all the way to the directrix, that right there is 8 units, right? If that is 8 units, the value of A is always going to be half that amount. And so here's what we know is for sure that must be 4 units and then 4 units, right? It's the same value of A. So A is equal to 4 in this situation. Finally, the last thing that we want to kind of make a note of before we go ahead and we write down the equation is notice that automatically then this parabola must be facing upward, right? Because it always faces towards the focus. It opens up into the focus, right? And the directrix is behind it. So basically you want to go to your formulas again and you want to consult the formulas and figure out which is the formula that talks about facing upward, right? Or opening upward, sorry. So you're going to have x minus h squared is equal to 4 multiplied by a multiplied by y minus k, right? And if you haven't made that connection, notice how the vertex is at 0, 0, right? So the vertex is updated by changing the h to a 0, changing the k to a 0. And not just that, recall A is the distance between the vertex and the focus, or the vertex and the directrix. So that right there is actually 4 units. And then the rest of the formula, I'm going to go ahead and fit it in. So this becomes x minus 0 squared is equal to 4 times 4 multiplied by y minus 0, like that. Okay? Now you can simplify this a little bit because once again, x minus 0 is a redundant thing to say. It's essentially x, so x squared is equal to 4 times 4, which is 16, and y minus 0 is simply y. So there you go. We have the equation, and they wanted us to find the equation, so we have completed the exercise. So I hope you're understanding that this is actually not that bad, and initially it looks like a whole lot to do, but basically you're looking at a handful of things. You're looking at which way does it open, right? You're looking for any one of these, right? You're looking for a vertex, you're looking for a focus, you're looking for a directrix, and you're trying to make a graph at the same time. So you're kind of playing around with these 5 options. And remember, the hidden recipe in this is A, right? What is A equal to? And A can be found in different kinds of ways, and we've discovered a handful of those ways as we've been going through it. All right, next example. It says find the equation of a parabola with vertex at 0, 0. So what we're going to do, as I told you, it's a very intelligent choice to make a graph actively. So as they're telling you stuff, just put it on the graph. You'll find that the problem is a whole lot easier to do, right? I to this day will do this is as soon as I'm reading these questions, I'll start making a graph out of it. It's so easy to tell many of these things, right? So first thing that they mention to you is the vertex is at 0, 0. All right? So vertex 0, 0. Now, the next thing it says is that its axis of symmetry is the x-axis. Now, I'm not going to draw anything here, right? Its axis of symmetry is the x-axis, but what we do understand is an axis of symmetry is something that splits something into a half. And so I can assure you that this parabola must either be facing towards the right or it must be facing towards the left. If you don't understand how did you make that connection, it's because think about it. If it's being split so that it's exactly a half in both directions, then what that means is it must be facing sideways, right? So I know that it's going to be facing sideways, right? But which side is the question? And so we'll talk about that next. Now what it says, its graph contains negative half comma 2, right? So they're not telling you exactly a a focus. They're not telling you a directrix. Instead, they're telling you that it contains the point negative half comma 2. And then your job is to find the focus, find the directrix, and then graph the equation, which we are trying to do actively as we go through these problems. So the first thing that we're going to do is we're going to write down a format, okay, knowing that this thing opens sideways, right? So what we're going to do is we're going to go ahead and write down x minus h, whoops, sorry, this is facing towards the sides, so we got to get rid of this really quickly, and we got to write down y minus k squared is equal to 4a times x minus h. Now, let's figure out, even though we only just have a point, is this going to be facing right or facing left? Now, what you'll notice is they told you that the point that's contained is negative half comma 2. What does that tell you? If the vertex is at the center, and you know that the parabola is going through negative half comma 2, right? Like, let's suppose negative half comma 2 is right there. What does that automatically tell you? It tells you that this parabola must be facing which way, right? It must be facing towards the left. You see that? So we knew that the axis of symmetry was going to cause it to become sideways, but now using that hint that they gave us about the additional point, we were able to tell that it's pointing towards the left, right? So let me go ahead and write that point in. negative half comma 2. Okay, so now what we're going to do is notice how we cannot tell a just by looking at what we have. We're going to find a way to figure out the value of a, because as soon as you can figure out a, you can figure out what the focus is and what the directrix is, and you can go ahead and make an equation completely. All right, so here's what we're going to do. We're going to update. We know that the vertex is at 0, 0. All right, so h, k is the vertex, and that's at 0, 0. So I'm going to write in y minus 0 squared is equal to negative 4a, because it's facing towards the left, times x minus 0. Now, this simplifies to y squared equals negative 4a times x. So what you do here is you use the point, all right, using the point negative half comma 2, we're going to solve for a. Meaning we're going to plug negative half and 2 into this equation and solve for what a stands for. You've actually done this skill when you learned about lines, right? So in other words, the negative half is going to go to where the x is, and the 2 is going to go to where the y is, right? And what that's going to do for you is it's going to leave you with basically an equation to solve that will help you tell a. So let's go ahead and apply this really quickly. Y squared is then 2 squared, and this becomes negative 4 times a times negative 1 half, like that, right? And so when you put these pieces together, you end up with 4 is equal to negative 4 times negative half is going to give you positive 2a. And when you divide by 2 on both sides, it's going to basically give you the value of a is equal to 2. And notice how the question didn't ask you for a, but you know that to tell a focus and a directrix, it requires a. So now that we know what a is, we're going to go 2 units, and we know that a is 2 units long. We're going to go 2 units in front of the vertex, and we're going to call that our focus, and you know that these coordinates would be negative 2, 0. Then we're going to go 2 units behind the parabola, and we're going to graph the line x is equal to negative 2, and you know that that's the directrix. And when it says graph the equation, well, we already graphed the equation. So let's summarize. The focus of the parabola is going to be at negative 2, 0. The directrix is going to be at x is equal to positive 2. I accidentally wrote down negative 2. I apologize for that. Okay. And the graph of the equation is, of course, right over here. So we have fulfilled everything that they asked in that question. All right, now we're going to find another equation of a parabola, and that pretty much is going to wrap up this lesson. We might try to make some time for some homework questions. It says find an equation of the parabola with a vertex at negative 2, 3. All right, so let's pause. And what have we learned is as soon as we hear these things, we're just going to go ahead and randomly start making a graph. Okay, so I'm going to go to negative 2, 3. All right, so negative 1, negative 2, positive 1, positive 2, positive 3. So at negative 2, 3, I'm going to go ahead and make a vertex. All right, and I will label it V, negative 2, 3. And then it says that the focus is at 0, 3. So now we're going to go and make a dot at 0, 3, which is right over here, and that is the focus. So I'm going to write down that the focus is at 0, 3. Now, this is the last example of the lesson, so I hope that you've realized that what that really means is this parabola must be opening towards what? the right, like this, right? It's not to scale, but you know it's got to be opening towards the right. So when it says find the equation of this parabola, well, it's actually not that hard to do. You know that it's a parabola that's opening rightwards, so let's write down the generic equation for that sort of parabola. We know that it's y minus k squared is equal to positive 4 times a, because it's facing towards the right, times x minus h, right? The vertex is at negative 2 comma 3, right? So h comma k is actually negative 2 comma 3. So having said that, we're going to write in that 2 comma 3. We're going to write down y minus 3 squared is equal to 4 times a multiplied by x minus negative 2. Now notice how the minus and the negative sign will make a plus, and we'll deal with that in a moment. But the last thing that we want to talk about, though, is the value of a, right? Now, for the last time, a is always going to be the distance between the vertex to the focus, or the distance between the vertex and the directrix. So if you go from the vertex to the focus, what is that distance, right? If you went from negative 2 comma 3 to 0 comma 3, I hope you understand that that would be a value of 2 units. All right, and so we can come back to our formula and we can update it and finish this process. Y minus 3 squared is equal to 4 multiplied by 2, which is 8, right? Again, a is 2, so this becomes 8 times x plus 2, and you don't need to do anything else with that equation. You can go ahead and pause there. And notice that the problem asks us to graph the equation. One more time, in the technique that I use to teach this, the graph is done actively. So you're reading the question, making the graph, and the problem is a whole lot easier to do. One last little comment to make before we wrap up is when you have to do the problems that are from 55 through 62, notice that in every single one of these questions, they've given you a vertex, right? Look at them carefully. All of them have a vertex, and all of them contain a point on that curve. So they've given you a vertex and a point. So to do these questions, I will not do any one of them because I literally just did one a moment ago. To do these questions, you simply need to go to the example that we did previous to last. And basically what we realized from this example is you need to figure out which way does it open, right? And after you figure out which way does it open, you can connect all the dots and solve for a, right? So here you have the graph already, so you already know which way it opens. So you need to go ahead and spend some time figuring out what's the value of a, right? And the value of a can be found by solving the equation, right? Work backwards in the equation as you saw in the notes, and you'll be fine with these questions. Thank you so much for listening to this part of the lesson, and good luck with the homework.